Ionic compounds. So what are ionic compounds? Ionic compounds are compounds that are formed when a metal reacts with a non-metal. So if you have a metal, such as in the case of sodium, reacting with a non-metal chlorine, these two are going to form sodium chloride. Now the sodium chloride is what is termed as an ionic compound. So in our lesson today, we are going to discuss the structure of ionic compounds and their properties. So let's dive in. Now onto the structure. When we talk about ionic compounds have a structure called a giant ionic structure. Pause. Ionic compounds consist of ions that are oppositely charged. So you're going to have ions that are positively charged attracted towards ions that are negatively charged. And this is what forms the basis of ionic bonds. And these attractions are very, very strong. Now when it comes to the ions, you're going to have a positively charged ion surrounded by negatively charged ions and so on. Now let me give an example in the case of sodium chloride. Now sodium chloride consists of sodium ions that are positively charged and chloride ions that are negatively charged. Now you're going to have a structure whereby a single sodium ion is surrounded by 6 chloride ions. Likewise, you're going to have a single chloride ion surrounded by 6 sodium ions on either side. So in short, you're going to have a single sodium ion alternating with a chloride ion and so on. So this pattern will keep on repeating itself until at the end of it, you have this huge 3-dimensional structure that is known as a giant ionic structure. Now, I know some of you might be wondering, a giant structure? Kwani, how huge is it? It isn't huge. When we talk about the term giant, we simply mean that you're going to have a structure whereby you have these tiny ions bonded to one another in a repetitive pattern, again and again in all directions until you have this structure that has literally so many ions making it up. And that is simply what we mean by a giant structure. And this is how it looks like. Now just imagine the table salt sodium chloride that you use maybe on a daily basis looks like this. Wondrous, right? Now moving on to the properties. So what are the properties of ionic compounds? Number one is that ionic compounds tend to have high melting and boiling points. A boiling point simply refers to a specific temperature whereby a substance changes from liquid to vapor state. So for example, if you want to heat water, when it reaches 100 degrees Celsius, water starts to evaporate. That is the boiling point of water. Now, melting point, of course, the temperature at which solids turn to liquids. Now, when it comes to ionic compounds such as sodium chloride, they tend to have a very high melting and boiling point. And the reason all comes down to the bonds. So the ionic bonds, those electrostatic forces of attraction that are present between the sodium ion, which is positively charged, and the chloride ion, which is negatively charged, are very, very strong. So the forces of attraction are very strong. So if you want a substance that is ionic to change from a solid to a liquid state or liquid to gaseous state, you need to break apart those bonds. And breaking apart bonds that are strong requires a lot of energy. And that is the reason why such compounds have high melting and boiling points. Moving on to the next one. Ionic compounds are soluble in water. So if you want to take an ionic compound such as sodium chloride, sodium fluoride, place it in water, it's going to dissolve. And the reason why it dissolves is because this compound, the ionic compound, dissociates in water. It simply breaks down. So instead of having sodium chloride, you're going to have sodium ions and chloride ions. So this makes such compounds very soluble in water. Now you'll find that when they dissociate in water, they tend to be attracted to water molecules because water is a polar compound. Moving on to our third property, and that is conduction. Now, ionic compounds can conduct electricity when dissolved in water. And the reason for this is because they have mobile ions. Now, when you take an ionic compound, dissolve it in water, it dissociates, it forms ions. These ions are mobile. They are continuously moving around. And by doing so, they are capable of transmitting the electric current. And therefore, they can conduct an electric current when dissolved in water. So, if you have a setup such as this, and you use copper 2 sulfate. Copper 2 sulfate is an ionic compound. If you dissolve it in water, it forms copper 2 sulfate solution, which will have mobile ions, copper 2 ions, and sulfate ions. Now, these ions are capable of conducting an electric current. So, if you have such a setup and you use strips of copper and zinc. These are going to serve as our electrodes. They are metals, so they are conductors of electricity. What will happen is that an electric current is going to be transmitted throughout. How will we know that an electric current is being conducted? Simple. By looking at the bulb. If the bulb lights up, which it will, that means the electric current is being conducted. So essentially, copper 2 sulfate, which is an ionic compound, can conduct electricity when dissolved in water. What is the reason, guys? Presence of mobile ions. Now, in the same instance, ionic compounds can also conduct electricity when in molten form. Pause. If you have a solid ionic compound, for example, if you have solid sodium chloride, it's not going to conduct an electric current. And the reason for this is because the ions are going to be in fixed positions. You need to have particles that are mobile for it to conduct electricity. But if the ions are in fixed positions, they cannot conduct electricity. But if you have an ionic compound that is either dissolved in water or in molten form, you've heated it until it melts, then it's going to have mobile ions and therefore will conduct electricity. And that, ladies and gentlemen, brings us to the end of this lesson. Be sure to tune into the next video where I'll be discussing covalent bonds. See you there.